Good morning, everybody, and welcome back to Calc 1. Today we're going to be starting Standard 13, where we're going to be learning how to find the formula for the tangent line of a function. And before we get started, wanted to give a joke of the day, because, just because we're online now doesn't mean we can't still do that. And so here's my question for you. What would mathematicians call a couple of MDs? Mathematicians would call a couple of MDs a paradox. But I'm just having people to laugh for me. Anyways, so here we're going to look at the function f of x equals the square root of x. And our goal in looking at this function is going to be to find a formula for the tangent line to that function at x equals 4. So we have a function here, f of x. I'm going to sketch out what the tangent line looks like at x equals 4. And this is going to be a linear function, L of x, where that is the tangent line to f of x at 4. So what properties should this tangent line have? Well, first of all, it's going to intersect the graph of f of x at x equals 4, meaning one property that we want our function L of x to have is that if we were to plug in L of 4, we want to get the same output as if we were to plug in f of 4, which by definition is the square root of 4 or 2. So it needs to be the case that whenever we plug in x equals 4 into our tangent line function L of x, we're going to get a y value output of 2. The other property that L of x has is that it needs to have the same slope as f of x does at x equals 4. How do we find the slope of a function f of x, or of L of x for that matter? Well, that's just going to be the derivative. So L prime of 4, we want to be equal to f prime of 4. And if f of x is the square root of x, or x to the 1/2 power, that's going to tell us that f prime of x is going to be 1/2 x to the negative 1/2 power, or 1 over 2 times the square root of x. So down here, if we want to know what f prime of 4 is, that's going to tell us it's going to be 1 divided by 2 square root of 4, which is equal to 1 over 2 times 2, or 1/4. So we know this about our tangent line, that at x equals 4, our tangent line is going to have a y value of 2, and we know that the slope of our tangent line everywhere, because lines have constant slopes, is going to be 1/4. And so now, what we're going to do is we're going to use this information to find the formula for our line. So L of x, we now know, is going to be a line passing through the point of 4, 2 with slope m is equal to 1/4. So what can we do with that information? Well, if we know a point on our line and we know the slope of our line, we can use the point-slope formula to find an equation for our line. So our point-slope formula tells us that a line has to have formula y minus y naught equals m times x minus x naught if x naught comma y naught is a point on our graph. So here x naught comma y naught is going to be the point 4, 2, and m is the slope. So plugging in that information, we know that at a value of x naught equals 4, we're going to get a y naught equals 2. And since our line has a slope of 1/4, which we found down here, that's going to tell us our tangent line has point slope formula of y minus 2 equals 1/4 times x minus 4. Or, if we wanted to simplify a little bit, we could get y is going to be equal to 2 plus 1/4 x minus 1/4 times 4, or y is equal to 2 minus 1 is 1 plus 1/4 x, 1/4 x plus 1. So that our tangent line in the end is going to have a formula of L of x equals 1/4 x plus 1. We can eliminate the y in the middle if you like and just write it like that. And so in general, whenever we're finding the tangent line to a function, we can use the point at which we're taking the tangent line to find a point, x0, y0, on the graph of our tangent line, in this case 4, 2. We can also take a derivative to find the slope of our tangent line. In this case, it had a slope of 1/4. And then using the point slope formula of a line, right here, we can plug that information in, and then that information will tell us a formula explicitly for our tangent line L of x. So that's it for this video. In the next video, we're going to talk about how we can generalize this process and find a general formula given any function f of x and a value at x equals a. How can we find the tangent line to f of x at x equals a using a general formula? Thank you all, and I will see you in the next video.